Today we're gonna start a new chapter, which is artificial neural network. As you can see that in this lecture, you might you also need to refer to the previous material which have been taught by Dr. Tink. Okay, especially these two nodes, which is um, the linear method for regression, supervised learning, as well as um, a linear method for classification logistic regression, because you will see that later this linear regression is very um, linear regressions is very related to artificial neural network, because later you will see that linear regression is actually a basic unit in artificial neural network. Okay, these are the outlined for this chapter, which is later we will talk about the some history and motivation of the artificial neural network. As you can see that in this history and motivation, you see that it will talk again about the linear classifier or a linear regression, and then we talk about the perceptron and as well as logistic regression. So you can see that the history behind artificial neural network, the basic process or the basic operations that have been executed inside the neural network is actually a logistic regression as well as a linear regression. So that's why we learned linear regressions or logistic regressions uh, uh, during our previous lecture, because that is actually the fundamental to understand artificial neural network, since we already covered a lot in the previous lecture. Linear regression doesn't matter, linear regression related to regression or linear regression related to classification. uh, Both actually is a component the important component in artificial neural network. Okay, just give you some clear view is that some book, the linear regression, when we talk about the linear regression, is actually in the previous note is related to uh, linear regression for regression. But if you're doing a linear regression for classification, some book call it as a logistic regression. So that is the difference between books two. But just the difference is that when you apply your logistic regression, then you have to cascade two function, which is a linear equation, a linear function with some non-linear function. Uh, but if you talk about linear logistic regression, actually is a cascading between a linear equation and sigmoid function. I think during the previous lecture, there's a two function have been introduced to you. One is a sigmoid function, another one is a softmax function. And sigmoid function is for the purpose of to classify or to make a binary classifier which can differentiate between two classes, while when you learn about softmax function, it's actually for multi-class classification, where you can have more than two classes. So that is, even the name is actually logistic regression, that does not mean that that is under machine learning for the purpose of regression. Okay, if you remember the introduction, during the introductions, we mentioned that supervised learning can be divided into two. One is regression, another one is classification. For regression, the output should be in continuous number, while for classification, the output should be in nominal or multinomial uh, mean the output should be in classes, in discrete number that represent the classes. But when we explain about linear regression, linear regression that linear regression is under machine supervised learning regression. But if you talk about logistic regression, even the names there call logistic regression, but actually that is actually is under classification. It's not under regression, because because we all because the purpose of logistic regression is just an extended version of linear regression. Okay, you extended your linear regression into logistic regression by added sigmoid function or softmax function. Then it become classification or classifier. Then actually that is actually for the purpose of to classify or to make the output become discrete that represent classes. Okay, so even don't confuse with the name, because the name there is taken from the linear regression. When you convert your linear regression as a classifier, it become or logistic regression. So the names there come from the linear regression, but now the purpose is different. It's under classification. It's not under regression anymore. And then later we will talk about the how actually the biological neurons, I mean the neuron which is from your brain, can be modeled, or can be where this is actually happens to the neuroscience community. Okay, when actually neuroscience is the people who try to do research, try to see the behavior of biological human brains, and then they come up with some mathematical model that to mimic the behavior of a neuron inside the human brain. So from that idea, actually, where the machine learning community or the artificial intelligence community try to take that formula, and it's become a model for computer to mimic the human brain characteristic or the human brain behavior. And then we talk about gradient descent and backpropagation. Of course, the gradient integration, the gradient descent here, we already covered a very deep and detailed in the previous lecture. So in this uh, title, we only focus on I just touch a little bit because you already uh, covered this one in the previous lecture. And what I want to highlight is a back propagation, which is actually back propagation is just a extended operation in neural network, where the unit or the mechanism is related to gradient descent. But to apply the gradient descent at the artificial neural network, then you need to apply these back propagations. Okay, and then I discussed a little bit about activation function. Activation function here is the one that you have discovered, you have been exposed before, which is the sigmoid function and softmax function. That is actually in regression or the linear regression. When you apply the non-linear functions, which is sigmoid function and softmax function, in neural network or in artificial neural network, that is what we call as activation function. And after that, I will discuss the example of backpropagations mechanism by using a simple AN model. I will give you some a simple AN model, then you can see the mathematical operation behind it. And finally, we will discuss about how to implement the ANN by using MATLAB. So I will give you uh, two different way in developing the ANN model. One is from scratch, another one is using the toolbox.